Yes, hello everyone. Today we are discussing a relative velocity question. Let's look at the question first. It says that a stick of length L is dropped from a high tower. An ant sitting at the lower end of the stick begins to crawl up at the instant the stick is released. Okay, so from the top of a tower, you are releasing a stick. At the bottom of the stick, you are having an ant which is climbing up the stick. Okay, velocity of the ant relative to the stick remains constant, and that velocity is u. Okay, assume that the stick remains vertical during its fall and the length of the stick is sufficiently long. Okay, fine. Then calculate the maximum height attained by the ant measured from its initial position and what time after the start the ant will be at the same height from where it started. So while reading the question, we should understand they are asking all these things. That is, calculate the maximum height attained by the ant and also the time after which the ant will come back to where it started. So if you understand with respect to the rod reference, the ant will never come back to its initial position. And with respect to the rod's reference, when will the ant reach the maximum height? When the ant reach the end point, right? So we have to understand something, that they are not interested in all the quantities with respect to the rod. That we have to understand, they are asking all the things with respect to the ground. So that's the first important thing. So if we understand that, then we can say we have to calculate all the things in this question with respect to ground. So what they have given is velocity of the ant with respect to stick. So can I say velocity of the ant with respect to stick is nothing but velocity of ant ant minus velocity of the stick. Now velocity of ant with respect to ground is what I'm interested, right? Velocity of stick initially, when the process has started, the velocity of the stick is actually 0. Velocity of ant with respect to stick is upwards, that is u. Velocity of ant, I don't know initial velocity, so let us call it as ua, initial value, right? Minus 0. Velocity of the stick initially, because they said from the top of the tower the stick is actually dropped. If you're dropping it now, the initial velocity is 0, and therefore we are getting that velocity of the ant is nothing but u, and it is upwards, positive. Upwards direction I'm considering as positive. Okay, what about the acceleration? That's the next thing. What is the acceleration of the ant with respect to stick? Okay, that is acceleration of ant minus acceleration of stick. Now with respect to the stick, the ant is actually moving with a constant velocity, they said that. So this value should be 0. Acceleration of ant with respect to ground, we don't know. This is what we are interested in finding. But acceleration of the stick with respect to ground, I know it is going down with an acceleration of g. Downward direction I should normally consider minus. See, my sign convention, I'm considering everything in upward as positive, anything downward, I'm considering negative. It's fine. So I can use like that. So acceleration of the ant with respect to ground comes out to be minus g. Okay. Now, first part of the question, they're interested in finding, calculate the maximum height attained by the ant measured from its initial position. So with respect to the initial position, from the initial position, how much height the ant has covered? That's the question, the maximum height. Okay, so with respect to ground, when I say initial velocity of the ant is u, deceleration it is experiencing is g. So that means after some time the ant's velocity with respect to ground will become 0. So can I say that is the moment, or that is the height which will remain maximum, because the velocity has become 0? How will it go ahead for? Furthermore, it cannot travel in the vertical direction. So that would be the maximum height. And that's why I'm using the general equation of our accelerated motion, that is v square minus u square equal to 2s. The reason for choosing the formula is, I know the initial velocity of the ant, it is nothing but u square only. I know the final velocity that the ant should achieve for the maximum height condition, and that is equals to 2 into minus g into this displacement is the unknown value. So I can substitute it, s is equal to, like that I can find out, s is equals to u square by 2g. This is the displacement covered by that ant when it has reached the maximum height. So from here, it has covered a distance of s, initial position. Okay, from initial position. Remember, this position or displacement that I have found is with respect to ground, as everything is with respect to ground. Now, next part of the question, they're interested in finding what they're asking: what time after the start the ant will be at the same height from where it started. So if the ant is at the same height from where it is starting, then what will be its displacement with respect to ground, right? Everything we are talking with respect to ground. So with respect to ground, what will be its displacement? Zero. So the second part of the question, displacement should be zero and they want time. So isn't it better to use the formula S is equals to ut plus half at square? Displacement is zero. We can take the t out common, plus half minus g t and a t outside. So basically I have substituted the values, the ua as u, acceleration as minus g, and then time I have taken out common. So two answers I am getting: t equal to 0 and t equals to 2u by g. So t equal to 0 obviously is initial time, so we should not consider that. So answer for our case would be this one. So it's a very good example. This kind of questions students should be doing with priority, right? With importance. The reason for that is the major problem that all of us face is selecting the proper reference frame. Okay, because if you choose a reference frame correctly, the question can become very easy. At the same time, if you choose a wrong reference frame, then the same question can be solved, but at the same time it will become very lengthy and tedious. So as a student, as a teacher, as a physics lover, we should be very smart enough in selecting the reference frame. That should be the more major important priority. So make sure that you have understood this, and if you have any doubts or any concerns, make sure to comment in the comment section. I'll be replying to that. Okay, so we'll stop here. A good question on reference frame. Thank you.